Right. So there was a B part to that question. They want us to show that angle CAD is equal to the inverse tangent of 2 upon root 3. So I actually drew triangle CAD here. Okay, I took it from, as you can see, the dotted line that I have there, CAD. So that is a right angle triangle, and I know that the distance of CD is 3D plus D more, so that distance here will be nothing but 4D, as we have determined from our answer in part A. So that was 4D. Okay, what else do we need to know? Well, we can actually calculate what the distance A to D is. And A to D, as you can see in yellow, is AF plus FD. Now, mind you that FD is the same distance as BE. All right, so first I'm going to find AF. All right, so I have that triangle here with all the necessary measurements. All right, that is the 2D for the hypotenuse, the 30 degrees here at angle A. All right, so also the BF, which is D, the distance is D, as we have calculated before. All right, so we can actually calculate the third side here. You can actually also use Pythagoras' theorem. Okay, so basically, if you were to find AF using Pythagoras' theorem, but I'm not going to use Pythagoras' theorem, I'm going to use the 30 degrees here. So I'm looking for AF, which happens to be the cosine of 30 degrees because it's next to 30 degrees. The cosine is AF over the hypotenuse of 2D. So AF then will be 2D multiplied by the cosine of 30 degrees. All right, so if you know your special angles, you will know that the cosine of 30 degrees is, if we go back to that triangle that we have, the cosine of 30 degrees is root 3 over 2. So that is root 3 over 2. Okay, so this is root 3 over 2. Multiply that by 2D. All right, so that means that AF here is going to be nothing else. So what you're going to do is you are going to cancel these 2's here. So AF is nothing but D times root 3. So this is D times root 3. Okay, so that brings us close. We have one distance. All right, so we need to find BE now, this distance BE. All right, why do I find BE? Because if you look at BE here, BE is the same distance as F to D. Okay, so I'm going to find BE. So I have the triangle with all its different measurements and stuff. So if I come here, I'm looking for BE. So that's also the cosine of 60 degrees, which is BE over 2 root 3 multiplied by D. Okay, so what is the cosine of 60 degrees? Well, if you go back to your special angles, you know that the cosine of 60 degrees is 1/2. Okay, so the cosine of 60 degrees is 1/2. So I'm going to say this is nothing but 1/2 equals to BE over 2 root 3. So if we kind of cross multiply, that's 2BE equals to 2 root 3. Okay, therefore BE will be nothing but root 3 because the 2's, they will cancel. Okay, so BE is nothing but root 3. Okay, so what is our distance of A to, if we come here, A to D is AF. A to D here, it will be AF plus, so AF plus BE, okay, plus BE. And what do we know? What is our AF? Well, AF was D times the root 3, and that obviously you can see from this triangle. And what is BE? Calculating BE is nothing but root 3. So this is nothing but root 3. Okay, all right, so this is what I have now. And of course, just make sure that you do understand that 2BE, there's a D missing here. So this is to a D here, all right? And then if you divide by 2, so you're going to get root 3 times D, okay? Root 3 times D. So just make sure we put that back there. Okay, at the end of the day, we are going to have D here also. So what is the final answer? The final answer then have to be 2 times this business here. So that is distance of AD. It is going to be 2 times root 3 multiplied by D. Okay, so we now know what AD is. We also know what is CD. So we can actually calculate the tangent. So the tangent of angle CAD is the opposite, which is 4D over 2, no, tangent, yes, opposite, which is 4D over, in fact, even if we look at the distance of AC, I just want to make sure of something here. Let's come back here. It's going to be 2D root 3, 2D root 3, 2D root 3 multiplied that by D. Okay, all right, so I think we can actually simplify this a bit. So if you simplify this a bit, you will realize that the D's cancel. 2 goes in itself 1 time and 2 goes there 2 times. So at the end of the day, the inverse tangent of that angle will be 2 over root 3. Okay, and surely this is what we were supposed to prove, as you can see from that. Good. I think while I'm busy with this, I can also go then directly to the next video. So the next video here deals with sequences. So it says the first term of a GP. So I always like to write the information that I have. I know it's the GP, and the first term is of a geometric progression in which all the terms are positive. The first term will be 50. Okay. The third term will be 32. So we need to find the sum to infinity, which is normally given by this particular formula. All right, so in order for us to find the sum to infinity, we need to know what is the value of R. So if I say this is equation, or this is my first and that's my second, so the first term is, remember when you are dealing with the rule for a GP, T sub n is ARN minus 1. So if we are now talking about the first term, then A will be A, which is, in this case, my A is 50. So it's going to be 50 multiplied by R, but it's like that. So we now know that the first term is 50. Then the third term will be 50 R3 minus 1, and that's going to give us 50R squared. Okay, so what we're going to do, we also know that the third term itself is equal to, that third term will equal to 32. All right, so let's say that is my second equation, and let's say this is obviously the value of A. So if you substitute the value of A into the second equation, all right, in order for you to find R, okay, because here we know that we have got the first term A to the R. A represents the first term. Okay, the first term is just going to be 50. So if we are substituting 50R squared, which is the third term, so the third term is going to be 50R squared equal to 32. And then the first term, so I just want you to bear with me. Okay, this one is going to be nothing but A, which is 50. Okay, A, which is, in fact, let's just write the formula down here so we can have a better way of understanding that particular question. Okay, so we're going to have AR square here, all right, which is this particular, the third term, over A. And we know that the third term is 32, and we know that the first term is 50. If we do it like this, then we'll have a way to find our R. Okay, so from here, let us cancel what we can. Canceling the A, leave you with R squared. Okay, half of 32 is 16, half of that is 25. I'm actually just simplifying. All right, so R will be nothing but the square root of 16 over 25, which is the same as the square root of 16 over the square root of 25, which happens to be 4/5. Now we know what the value of R is. So once we know the value of R, we can actually find the sum to infinity. So the sum to infinity will be, the sum to infinity will be A, which is 50, over 1 minus 4/5. Okay, so this answer here will be 250 if you multiply it out. There's a B part. The B part says the first three terms of an AP. So I know now this is an arithmetic progression. The first term, term 1, is nothing but 2 sine x. Okay. Term 2 is nothing but 3 cos x. And term 3 is nothing but, in brackets, sine x plus 2 cos x. Right. So what do we know? In order for us to find the common difference, we take term 2 minus term 1. We say that is equal to term 3 minus term 2. That is in order for us to find the common difference. Okay. So term 2 happens to be 3 cos x minus term 1, which is 2 sine x, should equal to, what is term 3? Term 3 is sine x plus 2 cos x. Take note, I'm not putting in bracket. So that's the third term, minus the second term, which we now put in bracket, or you can just leave it like that. It's okay, minus 3 cos x. Okay, eventually we'll have to collect like terms and stuff like that. So I'm going to have the 3 cos x here. I'm going to add 3 cos x over there. Okay, that is this one here. And here I have sine x. So I am also going to bring the other one over by adding, that is this one here, adding 2 sine x. Eventually, this is going to give me 6 cos x equals to 3 sine x. All right, so we are nearly there as far as our answer is concerned. So you have got 2 sine x, that is sine x, and then you have got, in fact, the cos x, we are not done. So the cos x is 3 cos x plus that 3 cos x, and then you have another 2 cos x. Can you see this one? Another 2 cos x here. So this 2 cos x should also be then subtracted because it's positive, so you're going to subtract it there. Okay, good. We are nearly there. So this leaves us with 4 cos x equals to 3 sine x. But we are supposed to give our answer in terms of 10x. So what you know also from tangent, and you should know this from your identities, you should know that 10x is nothing but sine x over cos x. Now, knowing that means I'm going to divide throughout by cos x here and cos x here. So that on this side now I have 3 10x because sine x over cos x is 10x and this is just 4. Okay, so the idea now is to make 10x the subject of the formula. So you'll say 10x is equal to 4/3. Therefore, we have proved that 10x is 4/3. Okay, as indicated in our problem over here. All right, I hope we have got so far. So then there's a Roman 2. Now this question wants us to find the sum of the first 20 terms. So what do we know? We know what is the first term. We know what is the common difference. Okay, now what is the first term? So if we go back to our problem. Our first term is 2 sin x. Okay, I'm just going to write it down like that. So our first term is 2 sin x. And then what is our common difference? Well, we can find our common difference by subtracting the terms from each other. So it's either I say 3, so I will also, it's either you say, because you have to actually find what is the value of x in order for you to find the common difference, okay? So it's either you take these two, subtract them from each other, or the other ones on that side. But 3 cos x minus 2 sin x, that is our common difference, okay? So it's 3 cos x minus, just go back to see if we can, minus 2 sin x, okay? Minus 2 sin x. All right, so what do we need? We actually need to know, okay, for the purpose of our calculation, we need to know what is this x value equal to. All right, in order for us to do so, we'll use what we're told that 10x is nothing but 4 over 3, if I recall correctly from that. So this is going to allow us to find angle x. And once we have angle x, we're just going to substitute it in there. So x will be the inverse tangent of 4 over 3. And what you do from this point onwards is you grab your calculator, okay? And I'm just going to find mine here on my very messy desktop. So we take the inverse tangent and make sure that your calculator is in degree mode, okay? And also clear everything that was there before. So I like to shift and then I clear with 9 and I say yes, clear everything, all clear. Good, all good to go, nothing in the memory. My calculator is in degree mode. So the inverse tangent, shift, inverse tangent of 4 upon 3. Okay, and then you can close. So hit equal to 53.13. All right, so this is 53.13 degrees, give or take. All right, so that means I can actually then calculate my value of a, which is my first term, and it's going to be nothing but 2 multiplied the sine of 53.13. All right, so let's go back to our calculator. I say, okay, 2 sine of 53.13, and I see what value I get. I get about 1.599999. So it's about 1.6. Okay. All right. Then I can also calculate this one here. So I'm going to say 3 cos 53.13, okay, minus 2 sine x. We already know what this one is, 53.13. Anyway, we're just going to use our calculator. So our calculator, then we hit 3 cos 53.13 minus 2 sine, we have this one already, 53.13. Good, we get the value. So our common difference is about 0.2. So what do we have now? We have our d value, which is 0.2. We have our first term, which is 1.6. Now we can actually find the sum of the first 20 terms. How do you find the sum of the first 20 terms? All right, I hope you remember. The sum of the first 20 terms is, the sum of first 20 terms is n over 2, in brackets 2a, then plus d multiplied by n minus 1. Okay, so we know that that is 20 over 2, then 2 plus our d, okay, let's just get that sorted. Our d, which can we calculate, multiply this by 20 minus 1, all right, in order for us to find. So let us just insert the values. What is our a? Our a was 1.6. I hope you still remember from our previous work here. Our a is 1.6. Our d is 0.2. So we're just going to insert those values and then we are going to multiply out. Okay, so again, grab the calculator. So that's 10 half of 20 in brackets. We have got 2 times 1.6. All right, then you add, then you have in brackets, you can say 0.2 times 9. Okay, whatever keeps you busy, you should arrive at 70. Good. So I hope you gave it enough thought and you also had a look through that question. There is quite interesting things in there that you need to remember.